Hello guys, today we're going to be doing lecture homework 7 of ENG4. Here's lecture homework 7. Basically, it's saying to create all model parts, assembly, and an assembly drawing from these two pages, 635, which is this drawing over here, and then 636, this drawing over here. For reference, you can go to the textbook and go to page 635 to 636, or in Canvas, you can go to reading list and go to page 331 or 332 to find the pages. So to start this off, we just need to design all the model parts first, then we're going to do the assembly, and finally do the assembly drawing. In the assembly, I'll also show you how to do multi-view and exploded pictorial, but that is completely unnecessary. You can do one or the other. I would suggest doing exploded pictorial as it will be a better practice and you learn a lot more while doing an exploded pictorial because it's all new stuff compared to a multi-view drawing which you've already done before. Okay, to start off, we're going to go to page 636 where all the parts are. As you can see, some of the numbers are skipped. Like for example, there's no part number 2, and then I think there's also no part number 7. As you can see in the bill of materials. This is called the bill of materials, by the way. It's basically a table which would say the item number, the quantity of the item, the name of the item, and any description that you want. And we will also input that in our drawing just in case the professor or TA wants to see it. Okay, first we want to start with part number 1, material steel. For that, open up SolidWorks, go to new, part. If you have this window, click on part. If not, you can go to novice, and you might have this window as well. Just click on part. Always make sure that you're in IPS. You want all your um, part systems to be the same. If one of them is MMGS and another in IPS, the assembly won't function correctly, so make sure all of them are in one unit system. I would suggest doing IPS because we're using ANSI system in this class, which uses IPS. Okay, so first we're going to do this. Try doing this part first. Try thinking of the design intent on how you want to design the part. So we know that this is a perfectly cylindrical model, meaning that it's symmetric over an axis. So that's a hint to what feature you might want to use in order to create this part. I'll give you a few seconds to think about it and then you can get started if you want. If not, you can follow along and just finish the part with me. Okay, so what I would do is first create a profile of the part and then revolve it around an axis. To do so, we'll go on the right plane and click Sketch. And if you aren't on the plane itself, you can go to Control 8 and it would bring you normal to the plane that you want to be on. And now I'll go ahead and click Centerline. And here I would put an infinite length and make it horizontal. I always make my center lines horizontal because it'll help me easily find out which one I'm revolving around. So in some cases, you have multiple center lines / hidden lines inside a sketch, so you want to always know which one you want to revolve around, and this will help me do that. It would also be easily visible over very big sketches. Okay, so to start it off, I'm going to set this point in the textbook sketch as the origin, so I'll start from there. Notice there's also a hole through the center of the, I think this is called center pin. Yeah. Notice there's a hole that's in through the center pin over here. So we would have a hollow middle. So I'll start a little bit above, like so, and go to the right, up, And I'll go at an angle. Usually you can chamfer later on, but I can show you how to chamfer like right away. So you can just go at an angle like this, and you'll see a white angle relation. That just means that you're at a 45-degree angle. It wouldn't actually put in a relation yet. It would just give you an approximation of 45-degree angle, and you can put the angle in later. So now I'm just going to go horizontal, up, left, and then down to finish the sketch. Okay, sketch done. Now I'm going to just add the dimensions. Go ahead and do this. If you don't know how to, then you can just follow along in the sketch, in the video. So here I'm going to dimension this part. Actually, not this part. Remember that chamfer thing? We should not overlook that. So it's from here to here is 2.5. And then from all the way to the right end to all the way to the left end is 3. And to get the diameter, you just simply click the line, click the center line, go below the center line, and you can get the diameter. This one we want it to be 1.5. Sometimes it creates like a wonky sketch. In those cases, just make your sketch a little easier for SolidWorks to understand. Okay, there we go. And then now we want to dimension the rest of it. So this one is 1, and this hole is 0.625. And then for chamfer, what it will tell you is the width and height, which is 0.06, times the angle of the chamfer. So the angle of the chamfer, which is always to a horizontal line, or horizontal to the or like an angle to the axis of the line, is 45 degrees. So this thing is 45 degrees. And then I'll just move my sketch around to make it easier to see. And then the height or width, you can select either one, is 0.06. Height or, yeah, width. And then what else do we need? Oh, right. All of these are right now are just moving around freely. We want to relate it to the origin. To do that, I'm going to click the bottom left point and the origin and make it vertical. Okay, sketch is fully defined, as you can see by the black lines, and fully defined at the bottom of your screen. What you can do now is feature revolve boss base, and since there's only one center line, it'll all automatically select that, and you can click OK. Okay, we are almost done. You can click on material, edit material, and it says steel. I would suggest doing alloy steel or ANSI 1020 because those are the most common types of steel used. I'll do ANSI 1020 this time. Apply, close. Okay. And if you can stick around to learn knurling, which is basically texturing the pin, but we are technically done with this part. So you can go ahead and save, and you can save it as whatever you want. I'll put this as homework 7, and inside the name of the part is center pin. I always suggest saving it in a folder because this is an assembly and you'll have multiple parts, and you can also save that assembly in the same folder. This means that whenever you need to give the assembly to another person, you can simply drag the folder, give it to another person through email and whatnot. So I always suggest doing that. Okay, so you can skip a little bit ahead, but we are done with this part. I will show you how to knurl or make this texture on the revolve face. This is something completely unnecessary. You don't need to know this, but it looks really, really cool. Okay, to do it, first what we're going to do is click on this face and hover over it and click sketch. So we're sketching on this face now. Click Control 8 in order to go normal to the profile. Click the outer circle and then do convert entities. This basically converts the circle and makes your sketch fully defined still because it's only relating to the circle that's already been created. Now what we're going to do is exit the sketch, go to click on the sketch, or if it's already clicked on, like there's a blue box, just leave it alone, and go to features. And if you're in full screen, you would see it already, but if you're not, you can go to this double arrow and click curves and go to helix and spiral. And now you can create a spiral. Usually the spiral is going out of the pin. To change the direction, you can go here and click reverse direction. And we want the revolutions to be 0.125 and the pitch to be 4. And what this would do is just create a line from here to here. Why I chose 4 and 0.125? 0.125 because it would just show the amount of revolution or the fraction of the revolution that you want. We don't want to go all the way. And 4, I picked that because one revolution will be 4 inches long. And this part's depth, I guess, is just 0.5. So you would do 0.5 times 0.125, or divided by, no, yeah, divided by 0.125, and you would get 4. And now you can click OK, and you would get this helix spiral thing. Pretty cool, right? Okay, now what we're going to do is go back to this phase, click Sketch, and Control 8 again, and we'll go to the top toolbar, drop down, and click Center Rectangle. Right next to the rectangle there's a drop down, you can click Center Rectangle. And draw it anywhere for now. Okay, now we'll click on the one of the horizontal and one of the vertical lines and click Equal, or Make Equal, and this would just make it a square. Dimension that square to be 0.05 inches. Very small square. And now what you're going to do is click on the center of the square. Make sure you're not normal to the profile for this one. Make sure you can actually see the curve you just made before. And hold Control, click the spiral that you made. And then here on the Properties toolbar, click Pierce. Pierce, basically what it does is pierces the point on another sketch. So if that sketch is anywhere perpendicular to the work plane that you're doing, it will pierce it at where the line intersects the work plane. So in this case, it would intersect it at this point. So it would pierce that line. Now go to Features while still in the sketch, and actually exit the sketch, sorry. Go to Features and go to Swept Cut, or Swept Cut. In the circle profile, if you haven't already selected, you can select the square. In the path, you can select the curve you made. And it'll create this really nice swept cut. Click OK, and there you have one of your knurling features. Now what we're going to do is circular pattern this around the entire face. To do that, you can go under linear pattern, the drop down, go to circular pattern, and for the direction, just click the circular face. And for the instant spacing and equal spacing, click equal spacing. Basically what it does is over 360-degree angle, you can put that in over here. It will create this many number of instances. I would keep it at 20. And then for the features, if it isn't already selected, go to this drop down and click cut sweep. And it would basically do the cut sweep, like so. Click OK. It takes a while. And now, the hardest part for the computer, really, for you, it's pretty easy, is first we're going to do a plane. And for the first reference, we're going to select this surface. And then for the second reference, we're going to select this surface. Basically, it creates a plane right in the middle. Click OK. And then the second thing we're going to do is do a mirror. So you can go under linear pattern mirror, or you can have a mirror tool over here. And for the mirror face slash plane, we're going to click the plane that we just made. And then for features to mirror, we're going to go under the drop down and click the circular pattern. And what it's going to do is create this very nice like knitting type behavior. And basically what it's going to do is the knurl type feature. Click OK, and your computer is going to take some time in order to compute this. It might take much longer than what it took me, or it might take a little less time. I don't know. But there you go. There's the knurl feature. Looks very nice, completely unnecessary, very consuming, very RAM consuming, but it's pretty cool to see it work. So yeah, that's how you would do a knurl in SolidWorks. Pretty cool. And we're done with this part. If you stuck along, great. You just completed something completely unnecessary, but very, very cool. So good job. Now we're going to go to the next part, which is part number 3, which is I think, the end plate, according to the bill of materials. That's what it's called. So go to new part and make sure again IPS units, and then go to the front plane. Also, I always encourage you to try it yourself and see how it's done. If you do not know where to start, then you can just follow along in the video. Click on center rectangle. I unclicked it. And go and make a center rectangle from the origin point. Now hold control, click one of the horizontal lines and one of the vertical lines and make equal. Basically it makes it a square. I made it a square here because it says 4 and then SQ, which means square. So yeah, and then now we can dimension it to be 4. Okay, now we're going to make another center rectangle, and this time it's going to be this inside rectangle. Yeah, so we're going to make that rectangle. To do that, we just click on the origin point again, and then now click somewhere on the center line. That is part of the previous center rectangle. Now hold control and click all the lines in the center rectangle you just made, and then here under options you can click for construction. Basically it makes it a construction geometry rectangle. Now what we can do is, if you drag it around, oh, this is a bad example. Okay, never mind, it perfectly did it. Last time when I tried doing this, it made it just coincident with one of the center lines and not both. If that's the case, then you can just click on the other center line, like drag the point and then click on the other center line. Anyway, we're going to now dimension it. So we know that it is 3 inches long. And now again, our sketch is fully defined. Now we're going to do all the circles that are in this. Okay, so go to the circle tool, make all the circles first. So over here and over here, and then from the origin outward. This would be for construction, but we'll change that later. And then all around. You don't have to make it really perfect, like for now they don't have to be exactly the same dimension that you want. We'll change that later. Okay, now that we're done, what we're gonna do is click the 4 circles in the center rectangle construction geometry. Hold control and click the areas or the lines and make equal. This basically makes all the dimensions equal. Click on this outer big circle, and under options click for construction. Click on these 4 circles and make equal, and now we can go right to dimensioning. So the outer ones are 0.25, the inner ones are 0.1875. The diameter of this big construction rectangle or circle is what is it? Oh, 1.625. And for the inner circle, it is 1. Sorry, I'm bad at reading dimensions. Okay, now we are done with the sketch. It's fully defined, and we have had all the features that are on the sketch in the textbook. So we can go to Features, Extrude Boss Base, and extrude it. So the thickness of this is 0.5, so we're going to put that in, and there we go, extruded. So now we can go to Materials, Edit Material, and again, you can click Alloy Steel and C1020. What I'm going to do is Alloy Steel SS for this one. That just means Alloy Steel Stainless Steel. And then save the part. You should save it under the same folder and name it End Plate. And save. There you go. We're done with that part. We can move on to part number 4, which is, I'm pretty sure it's called the disc. Yeah, the disc. Okay, so go to New, Part, and we're going to try doing this. Again, you should try doing it yourself. Make sure your unit system is the same as all the other parts that you did. Try doing it, remember design intent, and yeah, go for it. If not, you can just follow along with the video. Okay, so I'm gonna sketch on the front plane, make a circle, make another circle from the origin, and make another circle from the origin. So this middle circle is going to be that construction geometry circle that you see in the part. Okay, so I'm immediately going to make it for construction. And now I'm just going to dimension all of them. So the outer one is 2. The middle one is 1.625. And the inner one is 1. Okay, now we want to try to do these little extrude cuts. We can do extrude cuts, obviously, or we can try trimming later on and trying to do like all of it in one sketch. So I'm going to do it the easy way for this one, which is just extruding and then extrude cutting later on. But what you could do is just making it in under one sketch, like just like that. And then doing a circular pattern around the circle 4 times using this linear pattern circular pattern tool, and then just using trim entities and cut this part. And that's how you would do all of it in one sketch. You can try doing that. I'll just do it the easier way, which is just extruding and then extrude cutting later on. So I'll go to Features, Extrude Boss Base. This one is 0.125 thick. And now we can go on one of the surfaces, click Sketch, Control 8 to go to Normal 2, and we can get started on sketching. So I'm going to go down, and to make an arc, you don't have to go to the arc tool. What you can do is hover over the point where the line starts, the second line starts, and then now it automatically creates like an arc. Try to make this horizontal, the endpoint horizontal with the starting point, and then go up again. Make sure you have that tangency relation you see over there with the circle and the slanted line, and the horizontal relation and this coincident relation. Okay, we're done with that. Now what we're gonna do is just make it a little bit outer. This is just to ensure that we cut everything and not leave this little portion out. What you can do instead of doing this if you want to be really careful, is you can click on the circle and go to convert entities, and then just trim entities and then trim the outside. That's another way of doing this. Now you can see our sketch is not fully defined, so we're going to define that. First of all, the center point of this arc is horizontal or vertical with the center point of this arc, this origin. So we're gonna make that relation. Secondly, the radius of this cuts are 1.25. So we're just gonna put that in. There we go. 1.25. For some reason it isn't. Oh, 0.125. That's why. It's too big. Yeah. Oh, and we forgot that sketch which made it coincident with the center line circle. So we can either draw the circle again, but what I'm gonna do is go under boss extrude 1, click the drop down, click the sketch and make it show. So just hover over the sketch and make it show. And this is going to show that center line circle that we drew. And now we can click the point of the center point of the arc and click the circle and make it coincident. Words. Anyway, now we're going to do a circular pattern. We can do it two ways. One is just doing a circular pattern in the sketch. I'm going to show how to do that here. What you can do instead is extrude cut first and then do a circular pattern later. Since we already did that plenty of times, we're going to try to do a circular sketch inside a sketch. Yeah. So we can go under linear sketch patterns, circular sketch. For the rotation, we can just click one of the circles. And then for entities to pattern, we're going to just click the shaded area, and it would make the instance as 4, and make sure this is 360 degrees and equal spacing. There we go. The sketch is fully defined. If it's not, try dragging around the shaded area, and you're going to see a point appear somewhere in the middle. Make that point coincident with the origin. That would make it fully defined. Yeah. Okay, now we're just going to do extrude cut through all. Okay, and we're done. If you want, you can go again to the sketch 1 for the boss extrude and hide. So now it's hidden away. Control 7 for isometric view, and we are done. We're going to go to edit materials, and again, some type of steel. I'm going back to ANSI 1020 steel, apply and close. And then save this part as disk. Okay, we're done with that. We're gonna move on to part 5. So, new part. This is called, I think, the spacer, right? Spacer, yes. Okay. To make the spacer, again, this is a really easy part. You can do it. I believe in you. If you just want to check your answer, go ahead and do so. Do not copy off of me for this one, or do not follow along in the video. Yeah. So for this one, I'm just going to do a front plane sketch and extrude boss base. It should look something like this. Again, edit material. This should be steel, some kind of steel. I'll go with alloy steel SS again, just for the fun of it. And save this part in the same folder as before as spacer. Great. Now part number 6, which is, I think, called support pin. Yeah. Okay, again, new part. Again, try to see how you would do the part. This is again a cylindrically symmetric part. I think all of them except for the end disc are cylindrically symmetric. So try to see how you can do this part and try to do it. If not possible, then you can just follow along in the video. Okay, so I'm just gonna do a right plane sketch. And what I'm gonna start with is the center line with infinite length for a revolution, and then I'm going to revolve this feature around an axis. An interesting point of the feature is that there are two chamfers located on either side of the support pin. This should also be accounted for. Before, what we did for the center pin was make the chamfer as part of our sketch. Now what I'm going to do is make the chamfer after our sketch and feature. So first I'm going to start with the midpoint line because I want to keep the origin right in the middle. Might be easier for later methods, later assembly. It's always a good strategy to keep like the origin somewhere in the middle of the sketch instead of at the end, because it turns out to be really useful later. And what I'm gonna do is just leave my sketch here and then make a center line going down, and then I'm just gonna mirror that sketch over the center line later on. Okay, so I know that the length of this end is 0.5, so I'm gonna put that in. Again, make sure your standard is IPS or whichever standard you prefer using. Yeah, and then I'm going to go from this line and then click on the center line and go right of the center line, which is going to give me the entire length, which is 2.5. Now I don't have to make this sketch because I already made this 2.5 length. It's already covering the 1.5, so I can forget about that. Now for the 0.25 diameter of the bigger circle, you can just click on the center line, click on this center line, not the line, the center line you have here, and then go below the center line and you can type your thing in. And then don't worry about this being lower than this, we can fix that later. So this one is 0.1875, click that, go below, 0.875, we are done. Now we're gonna do just mirroring. So hold control, click all the lines. Oh wait, I messed up. What is happening? Let me just control Z. Okay, I guess this line is already across, so I don't have to mirror this. I'll just have to mirror all of this. So I'll just hold control and click the center line, or click the lines, and then click mirror entities, mirror about, click the center line, and click OK. We are done. Now we can just go to features, revolve, and for the axis of revolution, since there are more than one center lines, it'll ask you to pick which axis you want. I want this one, so I'll just click OK. And we are almost done. We just need the chamfers and the material. So for chamfer, you can go here under fillet. There's a drop down. Click chamfer and do an angle distance chamfer. So the angle is 45 degrees as it says over here, and then the distance is 0.325, 0.325. And then for items to chamfer, just click the face, I guess. You can click the face, or you can more ideally click the actual point and that. And you can also show full. For some reason my preview isn't working. I wonder why. Oh, it's 0.0325, that's why. Okay, 0.0325 inches, 45 degrees, and click OK. Okay, we are done. Just the material of the part, and then we're done. So the material, I'm again going to go with ANSI 1020, apply, close, and then save this part as a support pin. Okay, we are done with the parts. We need to do the assembly and the